Hey y'all! Today I'm going to unlock the power of C++ structs, Chapter 9 of Programming in C++. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free and it takes less than a minute. So let's dive into structs. If you're looking to master structs, you're in the right place. Let's dive in. First up, let's talk about accessing struct members. A struct in C++ is like a blueprint for a house. Each room or member has its own purpose. You access these members using the dot operator. It's as simple as calling. Easy peasy lemon squeezy. Now let's move on to comparison using relational operators. Imagine you're comparing apples to oranges. With structs, you can use operators like or to check if two structs are the same or different. Just remember, you need to overload these operators for custom comparisons. On to assignment. Assigning one struct to another is like copying all the rooms from one house to another. Just use the assignment operator. But be careful with deep copying when dealing with dynamic memory. You don't want to end up in a memory leak swamp. Suppose that you want to write a program to process student data. A student record consists of, among other things, the student's name, student ID, GPA, courses taken, and course grades. Thus, various components are associated with a student. However, these components are all of different types. For example, the student's name is a string, and the GPA is a floating point number. Because these components are of different types, you cannot use an array to group all of the items associated with a student. C++ provides a structured data type called struct to group items of different types. In C++, the dot, C, is an operator called the member access operator. Grouping components that are related but of different types offers several advantages. For example, a single variable can pass all the components as parameters to a function. The only built-in operations on a struct are the assignment and member access operations. Now let's talk a little about accessing struct members. The components of a struct are called members. In arrays, you access a component by using the array name together with the relative position index of the component. The array name and index are separated using square brackets. The members of a struct are enclosed in. To access a structure member, component, you use the struct variable name together with the member name. These names are separated by a dot, period. The members of a struct statement are separated by semicolons. The syntax for accessing a struct member is struct variable name dot member name. I know we covered a lot in this first section. Let's move on to the next section, right after this quick break. Alright, let's move on into assignments. We can assign the value of one struct variable to another struct variable of the same type by using an assignment statement. Given a struct variable named student and a member variable GPA of type double, the statement student.gpa equals sign 0.0 initializes GPA to 0.0. Assigning one struct to another is like copying all the rooms from one house to another. Just use the assignment operator. But be careful with deep copying when dealing with dynamic memory. You don't want to end up in a memory leak swamp. Comparison relation operators is our next topic. To compare struct variables, you compare them member-wise. To compare struct variables, you compare them member-wise. As with an array, no aggregate relational operations are performed on a struct. For example, suppose that new student and student are declared as shown earlier. Furthermore, suppose that you want to see whether student and new student refer to the same student. Now, new student and student refer to the same student if they have the same first name and the same last name. Components of a struct can be of different types. Input and output with structs, no problemo. Use and just like you would with any other data type. But remember, you need to overload the and operators for custom input and output. Think of it as teaching your struct how to speak and listen. Struct variables and functions. No aggregate input-output operations are allowed on a struct variable. Data in a struct variable must be read one member at a time. Similarly, the contents of a struct variable must be written one member at a time. A struct is a structured data type. Next up, struct variables and functions. You can declare struct variables just like any other variables. And yes, you can pass structs to functions. Pass by value for a copy or by reference for the real deal, just like lending a book versus giving it away. Struct variables can be declared as part of the struct definition. Recall that arrays are passed by reference only, and a function cannot return a value of type array. Data in struct variables must be read one member at a time. A struct variable can be passed as a parameter either by value or by reference. A function can return a value of type struct. The following function reads and stores a student's first name, last name, test score, programming score, and GPA. Given a struct variable named student and a member variable GPA of type double, you would read a value into GPA with Sinduri. Student.gpa. That covers assignments, comparison, relation operators, input, output, and struct variables and functions. Let's see what is next on the agenda. We will find out right after this break. Now let's get fancy with arrays in structs and structs in arrays. The previous discussion showed us that a struct and an array have similarities as well as differences. Arithmetic is not permitted on structs or arrays. Put an array inside a struct? You betcha. It's like having a bookshelf in your house. A list is a set of elements of the same type. Thus, a list has two things associated with it: the values, that is elements, and the length. Because the values and the length are both related to a list, we can define a struct containing both items. Student type student is a statement that declares a variable named student of the struct type student type. On to structs in arrays. You can also have an array of structs, which is like having a whole neighborhood of houses. Handy, right? Suppose a company has 50 full-time employees. We need to print their monthly paychecks and keep track of how much money has been paid to each employee in the year to date. Using structs in arrays is the solution. Last but not least, structs within a struct. Yep, you can nest structs like those Russian nesting dolls. It's a great way to organize complex data. Each nested struct can represent different levels of detail, keeping it all tidy and manageable. You have seen how the struct and array data structures can be combined to organize information. You also saw examples wherein a member of a struct is an array and the array type is a struct. In this section, you will learn about situations for which it is beneficial to organize data in a struct by using another struct. A struct may contain more than one struct, but not of the same type. And there y'all have it, a comprehensive guide to C++ structs. We discussed records or structs, then moved on to talk about accessing struct members. From there, we went to assignments, and then comparison relation operators. From there, we moved on to input-output, to struct variables and functions, the on to arrays versus structs, arrays in structs, and structs in arrays. Then we closed with structs within a struct. From accessing members to nesting them like a pro, you are ready to dive into Chapter 9. Remember, practice makes perfect, so get coding. If you liked this video, don't forget to like, subscribe, and hit the bell icon for more programming tips. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. See you on the next one.